This video will cover the Geometry Common Core exam from August 2015, questions 29 through 31. Number 29 says triangles RST and XYZ are drawn below. If RS is 6 and ST is 14, XY is 9 and YZ is 21, and angle S is congruent to angle Y. Is triangle RST similar to triangle XYZ? Now, in order to be similar, we have three ways that we can talk about justifying similarity. The first way is angle-angle similarity, where the angles are congruent. The second way is side-side-side similarity, where the sides are in proportion. And that's all three pairs of sides. The third way is side-angle-side similarity, where again the sides are in proportion, but we also have a pair of congruent angles. So if we look at this, it looks like we might have side-angle-side based on the markings that we have on the diagram. But we actually have to make sure that the proportion works out. So let's go with small triangle over big triangle. Set up a proportion between those corresponding sides. So for example, 6 matches up with the 9, equal sign, question mark. 14 matches up with the 21. And if you're not sure how I got that, I'm thinking about this statement up here, RST and XYZ. So RST maps to XYZ, which means that R, if I put a circle around R, I should put a circle around X. If I put a square around S, I should put a square around Y. If I put a cloud around T, I should put a cloud around Z, because again, corresponding parts match up. So here, when I cross multiply, we end up with 126 and 126. Because these are equal, they check out, which means that I have to choose between one of these three ways to justify triangles are similar. I did not have two sets of angles that were congruent, so I'm not using AA similarity. I did not talk about three sides being in proportion, I only talked about two. But I did use side-angle-side similarity because we had a side, the included angle, and another side. The sides are not congruent, but remember in proportion, which is why we solved that proportion, that fraction equals fraction. So here, the triangles are similar by side-angle-side. So yes, by side-angle-side similarity. And when it says justify your answer, that means show the math. Show all of that work that we already did and state why. Number 30 says, in the diagram below, triangle ABC and XYZ are graphed. Use the properties of rigid motions to explain why triangle ABC is congruent to triangle XYZ. Remember that a rigid motion is something that preserves distance. So here, if you look at these two triangles, we can pull out some of the coordinates, like A is currently at 1, 2, 3, 4. B is at 1, 2, 3, 4, 5, 1, and C is at 1, 1. A prime, oops, we don't have primes here, we have X, Y, Z. So A matches up with X based on this statement here. A matches up with X. So X is at -1, -4. Y is at -5, -1. And Z is at -1, -1. So you'll notice looking at the coordinates, we go from X, Y, the originals, and it looks like we're negating them. -1 is the opposite, or the negation of +1. And then that +4 becomes -4. +5 becomes -5. So again, negating our coordinates. If we negate both, that's the same as either a rotation of 180 or a reflection through the origin. Reflection through the origin. So here, if we have a rotation, we know that a rotation preserves distance. Or you can talk about the reflection through the origin. I'm just going to stick with rotation. Rotations preserve distance. So congruent lengths were formed, creating congruent triangles. Again, rotations are rigid motions. They preserve distance. You have to mention the fact that you have a transformation like a rotation and the fact that it preserves distance. This is a 2-point question, and the 2 points come from those two things, the transformation and the fact that it preserves distance. Number 31 says the endpoints of DEF are D and F at 1, 4, and 16, 14. Determine and state the coordinates of point E if DE to EF is 2 to 3. So here there's a total of 5 parts. So what we need to think about is taking segment DF and splitting it up evenly into 5 congruent parts. And we're going to find point E when it's 2 parts away from D. Again, 2 parts from D because I start with D, move towards E, and I'm 2 parts away. And then if I were to move towards F, that would be 3 parts away. So you can see that I grabbed a piece of graph paper here. You also have grid paper on the back of your test. And so I'm going to take a second just to plot D and F. Of course, that 1614 is not exactly going to fit the way my graph paper is aligned right now with the axes, so I'm actually going to make new axes. Let's see if I've got a tool to do that. Ooh. Okay, so let's make one axis here, one axis, and the other one we'll do here. Okay, so I just changed the colors on them so that it would be less distracting. So I'm going to plot over 1 up 4 for point D. And over 16 up 14. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And that's point F. So I'm going to connect them. If you have a straight edge to connect them, that would be very helpful. If not, then just do your best to make it as straight as you possibly can. So what we first have to do is find the change x and the change y of our original points. Change, of course, means to subtract. So first I have 16 minus 1 and 14 minus 4 for the y's. 16 take away 1 is 15, 14 take away 4 is 10. Now if you did it the opposite way, 1 minus 16 or and 4 minus 14, you would end up with negative 15 and negative 10, which is fine. Just ignore the negatives. Change them to positives because it doesn't matter in this type of question. So we know the original changes are 15 and 10 for the x's and then the y's respectively. But we said that we need a total of 5 parts. So now I need to find new changes. New change x and change y by taking the original 15 and 10 and dividing by my number of parts. So again, it's original change divided by number of parts. So 15 divided by 5 is 3, and 10 divided by 5 is 2. Now 3 and 2 are not the coordinates of the point E. This is telling me what the new change is. So I have to go over 3, up 2. So on the graph, I'm going to start at D. I'm going to go over 3 and up 2, plot a point. Over 3, 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 up 2, and I land on F. If I don't land on F, then I did something wrong. Something's wrong with my calculation, or I plotted points incorrectly. So what you can see here is that we have split up segment DF into 5 congruent parts. Here, 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 and here. 1, 2, 3, 4, 5. So then I need to go 2 jumps away. Remember, the ratio here is supposed to be from DE to EF 2 to 3. So I go 1, 2 jumps away, which leaves me right here, point E. Now I have to state the coordinates of that. So here I'm going over 1, 2, 3, 4, 5, 6, 7. So E is at 7, comma, and then we're going up 1, 2, 3, 4, 5, 6, 7, 8. E is at 7, comma 8.